Hello friends, this is Sunil Singh Hemar and today I will discuss about the friction stir welding. This is a very interesting topic especially for me because I have done my PhD work on this friction stir welding and corrosion of the friction stir weld joints of aluminum alloys. So today I will discuss about this friction stir welding, but first of all I will tell you about background of this welding technique. So when we listen about this welding, then some pictures of welding comes in our mind, like we imagine the roadside welding where one electrode is used and flame is generating and melting is occurring and some pollution is there, like this. But friction stir welding is a different kind of welding. This is not a fusion kind of welding. This is a solid state joining technique. Solid state meaning there is no melting occurs and no pollution is there, no fume is there. So this is a kind of a green technology, we can say. And this is not a much old technique. This was invented in 1991, that is about 30 years before. And this was invented at the Welding Institute, TWI, the Welding Institute at UK. So this became very popular, especially for aluminum alloys or low melting point alloys like magnesium alloy. And if there is no melting, then how this is possible to join the material? So this is due to the plastic deformation and frictional heating. What is plastic deformation? As we know that we use stirring machine in milk to produce the butter. So that kind of stirring is occurring here also, because the pin of the tool, one pin of the tool is inserted into the base material or the interface of the two plates where we want to join the material, and it will stir. So the back side material will go front side and front side material will go back side. Like this means material is stirring around the pin, and due to this that kind of plastic deformation, this welding take place. So and so I have used the word plastic deformation along with the frictional heating. That is the heating produced due to the friction between the solder of the tool and base material surface. Okay, so this is about the friction stir welding, and now I will show. I have the actual friction stir welding tool and weld joint. I will demonstrate that, or I will show you. And this, first of all, this is friction stir welding tool, and upper part, this part is called tool shank. This second part is called shoulder. Okay, shoulder. And third part is pin or probe. So first of all, we will clamp this tool into the friction stir welding machine or vertical milling machine we can use for this welding. We will clamp this shank part into that machine and rotate at high speed, or like 300 rpm, 500 or 1000 or 1500. And then like methodology, how this welding take place. Methodology: suppose we have this is one plate and we want to join this plate with one another plate, and we will clamp. I am just showing this gap, but there should not be any gap between these two plates. These plates will be firmly clamped with each other. Okay, and a tool is used here like this. This is FSW tool. This is clamped in a machine this is the tool. This tool is in rotating position. And what are the different part of this tool? This is shank, this is shoulder, and this is pin, tool pin. So these are three major parts of this tool, and this tool is in rotating position. This is rotating, and in rotating position we will bring this tool close to the surface of the plates. First this pin will touch to the surface of the plate, and then in rotating position we will insert this tool until shoulder touch to the surface of the plate, and then we stop for not stop, but we will wait in rotating position. We will wait here for some 1 minute or 30 seconds. That is called dwell time. During dwell time, this due to this friction between shoulder and surface, there will be frictional heating, and material in front of this tool will get heated, so that it will become soft. Then we will start to traverse in the direction of welding or our interest. We will traverse this, that is called at traverse speed or welding speed, and at the end we will stop the movement, but in rotating position only, and or we will exit this tool from this base material. Okay, and then the weld will be produced here. So how this weld will appear, I will show you. Like first of all, these are two plates which we want to weld, two different plate. We will clamp these plates, and after firmly clamping, this tool will be inserted in this at the interface of these, and then in rotating position we will traverse this tool and exit here at the end. So welding will take place. So how weld looks like? Weld look like this. This is the starting point where we inserted the tool and traversed in this direction, and here the tool exit. Okay, so this is a impression of pin and shoulder where the tool exit from this plate. So this is the welded plates. These were two different plates. Here we can notice some line. Okay, so now it is a very good or sound weld. We cannot break it with hand, or this is a weld of aluminum alloys. Okay, so next is the various terms which are generally used in friction stir welding. These are, we can say, parameters. These parameters used for friction stir welding, like speed parameters, rotational speeds, traverse or welding speed, that is the linear movement of the tool. And then this is one is tilt angle. Tilt angle is the angle that is given to this tool for effective forging action, so that the material behind the pin or under the shoulder will not go out or spread out from this region under the shoulder. So we will provide some tilt angle to the head of the machine. Then dwell time, as I discussed about the dwell time earlier, and the time given before the movement of the tool. So these are mainly used parameters in friction stir welding. And what is the material of the tool? Tool material should be very high wear resistance, and that can sustain at high temperature during welding, because temperature generally goes in nugget zone about 500 to 600 degree. In case of aluminum alloy, it depends on material of the base metal, and but it will be less than the melting point of this base material. So generally for aluminum alloys welding we use a die steel kind of tool, or for steel welding or mild steel welding we use a tungsten carbide tool like this. There may be some very hard material or very costly tool like PCBN. Now I will discuss about the various regions. What type of regions means? When we cut the sample from the weld joint. Suppose earlier it was this is metal 1, this is plate 2, that were joined from here. Okay, so this is the region where pin was stirring. This is called nugget zone or stir zone. Then there is second region. Thin region. This is called TMAZ or thermomechanical affected zone, and next is the heat affected zone, HAZ, and next is the base metal. Okay, this is the base metal where no change in microstructure take place or no change in the properties occurs. So first one is the nugget zone at center, nugget zone or stir zone. Second one is the thin region, that is TMAZ. Full form of this is thermomechanical affected zone. Then next is the heat affected zone. Experience only the heating or thermal cycle of the weld, and microstructure change may take place due to the thermal cycle only. But TMAZ experience thermal cycle as well as plastic deformation in this region. So in TMAZ generally elongated grains we can observe, but in case of nugget zone there is recrystallized grain due to plastic deformation, and then heat affected zone and base metal. Okay, so most of the time in case of aluminum alloys, heat affected zone is the severely affected region where the properties of that material is degraded in terms of mechanical strength or corrosion resistance. And so most of the time researcher work to reduce this heat affected zone in the weld joint. So this is kind of heterogeneities in the weld joint. Okay, and next, what are the advantages of you may think that why we are using this such kind of welding when we have fusion welding or conventional welding is there. But some material like aluminum alloys, these are very reactive to the environment, and due to melting, due to melting during fusion welding or conventional welding, these may get some kind of porosity or defects like solidification, cracking, or porosity. Due to these things, these are not possible in case of friction stir welding, because there is no melting and this is a solid state joining technique. So this is the advantage over that fusion welding. One more thing is low melting point material can be welded easily, because material not get melted during this welding, and so the various elements don't get vaporized during the welding. And this is very useful for like aluminum and magnesium alloy. Magnesium alloy also have very low melting point, not so much high. So these are advantage. There may be some kind of defect of its own, kind of like tunnel defect, or there can be root defect, or any kind of surface defect can be there. But if we optimize the parameter like speed, welding speed or traverse speed, then we can we can produce a very sound or defect free weld joint. So there is also some variant of this friction stir welding. These variants are like friction stir processing, FSP, friction stir processing. This is not a welding technique, but this is similar to all the things are similar. Processing parameters are similar to the friction stir welding, but this is not used for welding. This is used for only surface modification. On a single plate we use this FSW tool, and this will modify the upper surface of the plate. So this is used for surface modification. There may be non-rotating solder or stationary solder FSW, stationary solder friction stir welding. There can be a bobbin tool kind of friction stir welding. So there are many variant of the friction stir welding. So this is I think this is enough, and this is all about the friction stir welding. And if you think that this is beneficial for you, this is if this is beneficial for you, then You can subscribe this channel and like the video. Thank you for watching.